lesson 4.2, using intercepts. Intercepts, basically, if you think of intercepting something in real life, what's happening? What's another word? Kind of like crossing paths. What's another word that starts with I that's a lot like intercept?
Intervene.
Well, kind of intervene, you could think of it like it. How about intersect?
Yeah.
Is it intercepting kind of like intercepting? There's accept. When we say intercept, that's C-E-P-T. When we say intersect, that's S-E-C-T. So they're really two different words, but they really kind of have the same meaning. So when we're working with intercepts, we're going to be talking about a y-intercept and an x-intercept. And every graph, whether it's a line or some other type of a graph, often they will have one or the other as an intercept, or they may have both. There may be a place where it is crossing the axes that we call intercepts. So the y-intercept, that's the y-coordinate of the point where the graph intersects. Well, which axis do you suppose it's intersecting? The y-axis. That's why it's called the y-intercept. So the y value from the point that the graph, and then in the case of what we're talking about here, linear equations, where's the line crossing the y-axis? And where it is, what's the y value? Well, what do you think we can always count on with regards to the x-coordinate of that point? It's always going to be 0. If it's a point on the y-axis, every point on the y-axis starts with 0 and then has a y value. Its x value is always 0. So we can always count on that for the y-intercept, it will be 0, y. The y value can vary. Okay, the x-intercept. That's the x-coordinate of the point. Again, we're talking about a place where the line crosses and there's a point there where the graph intersects the x-axis. X-intercept, x-axis. Well, what can we count on for the y-coordinate of all those points? It better be 0 also. All the points on the x-axis have a 0 for their y value. All of them. So since we get to count on that all the time, that's kind of useful when we want to find these without the graph. So not every graph necessarily has to have both intercepts. Can you think of any time when we have, let's just talk about lines. Can you think of any time that a linear graph would not have two intercepts? It would not cross both the x-axis and the y-axis. A horizontal line. If a horizontal line is just going left to right, will it ever cross the x-axis? The only time it will is if the horizontal line is the x-axis itself. If it's the x-axis itself, then it's on top of the x. It is crossing the x-axis, but in more than one spot. It's laying on top of it. But any other horizontal line on the graph would only have what's the only axis it's going to cross?
Y.
The y-axis. So any horizontal line is only going to have a y-intercept. Can you think of any other times then that there may not be both of the intercepts? Alice? What about a vertical line? Would a vertical line cross both axes? Which one would it cross? The x-axis. This one's only going to cross the x-axis because the x-axis goes back and forth. So the vertical line will only cross the x-axis unless it's on top of the y-axis. If it's on top of the y-axis, it's of course crossing the y-axis many times, but that's not an intercept then. So any other type of line do you think would have both intercepts? So horizontal is going to have a y-intercept. Vertical is going to have an x-intercept. What do you think about other types of lines? What do you think? Do you think they'll all have two intercepts?
Yeah.
Yeah, they actually will. All the rest of them should have crossed the y-axis somewhere and the x-axis somewhere. Okay, we're going to find intercepts today. One of the ways we can find them is if it's already graphed for us. So in number 1 here, we have our line already graphed for us. We have no idea what the equation is. They just want us to find the y-intercept and the x-intercept. So if we're looking for the y-intercept, we're talking about the point that's what? Which axis are we going to look at? The y-axis. There's our y-intercept right there. What's its ordered pair name?
0, 2.
0, 2. Its ordered pair name is 0, 2. So we say the y-intercept is 2. It's the y value of that point. Well then, what is the x-intercept? We go to the x-axis and we see where's the line crossing the x-axis. It's crossing at negative 2, 0.
It's negative 3.
Is it negative 3? Oh, I've got that. Yep, it is negative 3. Thank you. Negative 3, 0. So what's the x-intercept? Negative 3. Okay, so when you're identifying these, though, you don't want to just put the numbers down. You need to give it some sort of a, like identity, like say, okay, this is. So you either can name them as the ordered pair, or you would say y-intercept. And I said to my class this morning, I said, I'll let you abbreviate like that. Y-int, x-int for x-intercept. So in other words, to identify which number is representing what. What is it actually standing in there for? So any questions about finding from a graph? That's the easy way, isn't it? Okay, what if we don't have a graph? Do we want to have to graph it? No, probably not. Why don't if they don't tell us we have to graph it, why would we go through that extra work? So instead, what we can do is we can do it algebraically. It says to find the x-intercept, replace y with 0, because remember, in the x-intercept, all the y values are 0, and then solve that equation for x. So we're looking for the y-intercept. What did I say, y-intercept? We're looking for the x-intercept. We'll put 0 in for y. What happens when you take 5 times 0? You get 0. Well, is adding 0 do anything? No. So why even bother undoing it and subtracting it? Just cross it out and say, you know what, adding 0 doesn't affect this equation at all. So we have negative 3x equals 30. Next. Divide by negative 3. So our x-intercept is negative 10. Or in other words, we can count on that the line for this equation would do what?
Cross the x-intercept, or x-axis at negative 10.
Yeah, if the line for this equation would cross the x-axis at negative 10. Okay, let's find the y-intercept now. How are we going to find the y-intercept? To find the y-intercept, replace x with 0 and solve for y. So, negative 3, put 0 in for x, add 5y equals 30. What's going to happen every time we multiply by 0? It's going to cancel. It's going to be gone. We can just go like this, can't we? And we have 5y equals 30. Divide both sides by 5, and what's our y-intercept? 6. Okay, so y equals 6. Okay, before you move on, I want to make sure that you understand that if we didn't have to graph this, but I want you to understand that this equation, does it have a table of values? Does it have a table with some ordered pairs in it? How many points are on the line of this graph? An infinite number of them. Can you give me any of the ordered pairs right now?
No. Negative 2, 1.
Negative 2, 1. Okay, and how do we get that? Where does that come from?
Negative 10, 0.
Negative 10, 0. We just found the x-intercept. There's one of the points in the table. Where's another point in the table?
0,
6.
0, 6. So instead of us picking x values and putting them into the equation and getting y values so that we would have some points for making our graph, we instead found 2 points. We found the intercepts, and we didn't have to be given any x values. How many points do you think it takes to graph a line?
2.
It only takes 2, doesn't it? For a straight line, you connect them and extend it on beyond those 2 points, and you have your straight line. So, how many other points would be in the table for this? An infinite number of them. So, the only way we've graphed them so far is by making tables, right? Have we done it any other way yet? We have some x values, we plug them in, get our y values, we get some ordered pairs, and we make a graph. Isn't that the only way we've done it so far? Okay. Well, today we're going to say when it is in standard form, using the intercepts is the most efficient way to graph it. Because when it's in standard form, you don't have it in function rule form where it says y equals, and here's the rule, put your x's into the rule and get your value for y. And when it's in standard form, it's not as handy. Remember back on the chapter 3 test. 3x plus y equals 4, 7, or minus something, I think it was. Some of you really struggled with that because you didn't know what to do with it. Is number 3 in standard form right now? Is that standard form?
Yes.
Because if it's not in standard form, the first thing you want to do is you want to put it in standard form, you guys. So you've got to decide if it is or it isn't. It is, okay. Then we can go right to work. We're going to find the x-intercept. So if we're finding the x-intercept, which one do we put 0 in for? Y. So show that substitution step. What happens when we subtract 0? Not a darn thing, right? So we have 2x equals 4. What are we going to do to both sides?
Divide by 2.
Divide by 2.
Oh, right. I guess that's what we do.
And x is 2. Okay? So the x-intercept is 2, 0. So we'll go to our graph, and we'll graph that one. We'll graph our ordered pair 2, 0. And now we'll find our y-intercept. When we're looking for the y-intercept, where's the 0 go? It goes in for the x. So 2 times 0 minus y equals 4. So 2 times 0 can cross out, but don't cross out that subtraction sign. It's going to be, yeah, if we change this to add the opposite, it'd be plus a negative y, wouldn't it? So this is really negative y then equals 4. Well, what's a negative y mean?
Negative 1.
It's negative 1y in reality, so what do we have to do? Divide by negative 1. So negative 1y divided by negative 1, 4 divided by negative 1, and y equals negative 4. Anybody have this one done already and have positive 4?
Well, I have that's right answer.
You didn't have the right answer. Okay, we will not draw straight lines without straight edges. So even in your homework, when you're doing it at home and you don't have a ruler to use as a straight edge, that does not let you off the hook. You find something that does have a straight edge to guide you. Okay? So I'm going to go to negative 4 on the y-axis and put a point. And with a straight edge, draw our line. And make sure it goes all the way through your coordinate plane. Mine's not very good. Try it again. And put arrows at both ends of your line. All the way through your coordinate plane. Don't just make this, like connect the dots and a little arrow past them. Extend it. Show that this line has lots and lots of points on it. Okay? So do you think now, anybody here, could you give me any other ordered pairs that would be in that table besides 2, 0 and -4? Am I thinking that they know some other ordered pairs that would be in this? Come on, there's all kinds of
1,
things.
-2.
1, -2. 1, -2. Right there. Give me another one.
3, 2.
3, 2. 1, 2, 3, 1, 2. Is that on the line? No. Oh, I went down instead of up. I'm sorry. 1, 2, 3, up 2. Okay, is that on your guys' line? My line might be a little bit off. Okay. So all we have to do is go to the line now and pick some other ordered pairs. If I asked you, okay, give me some other points that would be in the table. Aaron?
1, -3.
1, -3. So 1, 1, 2, 3. I think we're going to have to go with 1, -2, aren't we? Okay.
Ooh, -1, -5.
-1, -5. Well, you got to be really careful though, because our coordinate plane doesn't go down far enough. It's really not at -5, it's at -6. So you got to be careful. You got to make sure you can tell ones that you can clearly tell from the graph. Okay. Okay. So, any questions about that? Okay. Then let's move on to this next one. 1/3 x minus 1/4 y equals 2. We're not going to worry about the fact that there are fractions. We're just going to follow the same process that says if we're looking for the x-intercept, what do?
Take y times 0.
Put 0 in for y. Yeah, so 1/3 x minus 1/4 times 0 equals 2. Well, remember multiplying by 0 is just 0, right? So we have 1/3 of an x equal to 2. This is where we're not going to use our calculators.
It's easy enough to figure out.
When x is being multiplied by a fraction, what do? Multiply by its reciprocal, which is 3 over 1 or 3. Yeah, so we're going to take 3. On this side, we'll make it into 3 over 1. And on the other side, we just have to make it 3. So we're going to take both sides times 3 is really what's happening here. And over here, we cancel out. We end up with our x alone. And what do we have?
6.
6. So x equals 6. Our x-intercept for our graph is at ordered pair 6, 0. Okay, next we'll find our y-intercept. So for our y-intercept, we're going to put 0 in for x and solve for y. Careful, careful, careful. This crosses out, but what's still there? Yeah, the subtraction now became a negative. Negative 1/4 y equals 2. What are we going to do next? Well, we're going to divide, but we don't want to use our calculator, so we're going to multiply by?
-4 over 1.
Yeah, negative 4 over 1. So we're going to take both sides times negative 4 over 1, or negative 4 on the other side. Don't really need it in fraction form on the other side. So here's where we're doing that. We're taking both sides times negative 4. Because our goal is to get y alone, and that happens. What's y equal? Negative 8. So we go to 0, -8, and plot a point. And draw our line. So when the equation is in standard form, this is the most efficient way to graph it. In your homework, they won't all be in standard form. Take the time to put them in standard form first, and then do your putting 0 in for the appropriate variable and getting that intercept that you're looking for to help you get the graph. Any questions?